So because all of life has this pattern built around it, then it means that all parts of life has a sensitivity built into it. Whether it's health or agriculture or forestry, water resources, it matters not. The sensitivity is pervasive. And if the sensitivity is embedded and it is pervasive, it is also significant. And really what I'm getting at by talking about significant is that it's disproportionate. So there are other countries in the world that are also sensitive to climate, but they share one or two of those characteristics. It's a Caribbean that shares all four. Our context is very simply one of sensitivity. You can see then why in Taylor's equation of state, variable A is sensitivity. And you know, before I leave it, that sensitivity tells us something about what climate is demanding. Because if we are so inherently sensitive to just the patterns of climate, then climate is demanding, first of all, attention. And that is attention even if the climate were not changing. We have an inherent sensitivity. Climate demands attention. Okay, but very quickly, let me move on. What would be my second observation? My second observation then would be this. Climate change is transforming our sensitivity into a vulnerability. What does that mean? You can guess it. It means that variable B in Taylor's equation of state is vulnerability. The context that we have is not just a context of sensitivity, but it's also a context of vulnerability. Vulnerability can be defined as a function of sensitivity, exposure, and capacity to cope. Well, I've just argued that we certainly meet the first criteria of sensitivity. And so it is true, the Caribbean has always been sensitive to changes in climate, simply because we are just inherently climate sensitive. So when the climate varies, we expect that all of life must also vary as well. We just have the sensitivity, and so we are vulnerable. And if the sensitivity is pervasive, then you can see that the vulnerability also has to be pervasive. Okay. What is climate change doing? Climate change is now moving us to new levels of exposure and challenging our capacity to cope. So in effect, what climate change is doing is moving us beyond our normal expectations of vulnerability to the occasional hurricane or heavy rain. And in fact, taking that part of who we are as determined by our sensitivity to climate and gradually making it into a liability because it's affecting our exposure and our capacity to cope. How do I come by this? Well, this is partly where the science helps us, because the first thing that the science really tells us is that climate is changing. And so, if we look at our temperatures in the Caribbean region, and I use the groundbreaking work of Dr. Tanisha Stevenson, who is in the audience, then you will notice that, boy, if I look on the top diagram, which looks on warm days, everywhere you see a red triangle that is upward means that the thing is increasing. What can you tell me about the warm days? It is clearly increasing. So if we look at the past 50 years, the number of warm days we have in the Caribbean have been increasing. And if you look to the diagram on the right, you can see that the trend is just upwards. And if you look on warm nights, you also see the same pattern, because the triangles are all upturned and red as well. And you can see that the trend is also upward. But you should also note that the upward trend is far more significant than for the warm days. It is true, it is hotter at night than at days. And then if you look on the cool nights, you can see that the number of cool nights we've been having in the region have been going down. So our temperatures, the science tells us, has been increasing. Our climate is changing. But it's not just the temperatures that have been changing, but it turns out that our rainfall is becoming more variable. And so the plot of rainfall I showed you before, you can see that the characteristic of the rain is that one year it is high, but then the next year it is down. And then the next year it goes back up, and we have a pattern of extreme variability. And the variability we have been seeing in relation to climate has been increasing in the recent times. And it's not just that the variability is increasing, but the character of rain is also changing. Tell me if you do not notice these things. we have a long pattern of dry. And then when it rains, it doesn't just rain, it rains. And so the character of rain is also changing. And that is how climate change is manifesting itself in the region. But it's not only that temperatures are increasing and rain is becoming more variable, but we're getting more storms and hurricanes. So if you look on the right plot, it shows you, if I take a 200-kilometer radius around Jamaica and look on just the last 12 years of between 2000 and 2012 rather, we have had 12 hurricanes or storms passing within 200 kilometers of us. But compare it to the 20 years before that, and there were only 4. Our number of hurricanes and storms have been increasing. Not all due to climate change, but climate change is playing a significant role. And then lastly, our sea levels are also rising. And so if we look throughout the Caribbean region, we see numbers for Jamaica very similar to numbers for the rest of the region and for the world. We have been increasing, our sea levels have been increasing by about 1.6 somewhere millimeters per year. But when you put all of that together, so you take the warmer temperatures and the more variable rainfall and the more storms and hurricanes and the higher sea levels, what emerges is a new climate regime. We are having to contend with the emergence of a new climate regime. And that new climate regime is marked by a couple of things. First of all, unfamiliarity. So the new highs that we're reaching and the new lows that we are going to are just simply unfamiliar to us. And so it is for that reason that the Met Service would write, the drought of 2009-10 was the worst drought in 25 years. And as a result, there wasn't enough rainfall to keep the water distribution in the end of the seas facilities to any parishes, especially for the highly populated Kingston and St. Andrew. I wasn't talking last year, this is 2009, 2010. But it's an unfamiliar pattern. And if it's unfamiliar, then it is also unpredictable. So we're going into a new climate regime marked by unpredictability. Yes, it is true, we have made significant strides in terms of predicting climate, but the regime we are in is also beating our strides of predictability. And so for that reason, the Caribbean Institute of Meteorology and Hydrology can write, the greatest challenge associated with that 09-10 drought was the region's inability to recognize the onset of the drought and the severity. The new regime is unpredictable. And if it is unfamiliar and it's unpredictable, it is also unreliable. Remember that seasonal pattern on which our reassurances had come to rely. It turns out that it is failing us. And so we can no longer expect that the rain at the end of the year is going to come to replenish the water supply so that the following year we can get through the dry period. It's unreliable. The pattern is becoming unreliable. And so it is for that reason that, one study can write that Caribbean farmers are lamenting the lack of reference points in the climate or even associated biodiversity on which to base judgments for planting and reaping. We are in an unreliable regime. When I first started at the University of the West Indies, you could apparently rely on the blossoming of the poor trees to study. If that's what you are relying on now, then you have already failed. We are entering then into a new climate regime. Our climate is changing. And that climate regime is marked by unfamiliarity, unpredictability, and unreliability. So what happens in this new climate regime of unfamiliarity, unpredictability, and unreliability? Well, it turns out that our levels of exposure are changing, and in that way impacting the vulnerability. What on earth do I mean? Well, it turns out that though we are all inherently sensitive, there are some parts of us that had less exposure simply because they had secondary linkages to climate. And so whereas there are some sectors that would immediately feel the link of a change, there are some sectors that would feel it later because of their secondary linkages. In this new climate regime, the vulnerabilities of sectors that were previously veiled because of their secondary linkages are emerging and emerging at a faster pace. Let me illustrate it with the headlines of the newspapers from last year's drought. You would expect some of these headlines, the ones you'd expect immediately, are headlines related to agriculture, food shortages. You'd expect the headlines related to water, and certainly you would expect the headlines related to forest fires. But very quickly after those headlines came headlines saying that education was being affected by school closures. And very quickly after education was energy was being affected because hydroelectricity and power outages important more due to dry conditions and salt on the sea lines. And then very quickly it moved to that the whole economy was being impacted. And that is of course due to impact on small businesses and economic productivity. Can you see that climate change is transforming those inherent sensitivities which were previously masked into real vulnerabilities, because the ripple is going much further and much quicker. But it's not only that, it's expanding the level of exposures by bringing out those secondary linkages, but it's challenging the levels of exposures in a second way. It turns out that as the climate is changing, new vulnerable groupings are also emerging, and that is because of this expanded exposure. What do I mean? Well, I only need to show you Caribbean terrace. Simply to say that what was once thought as distant and unreachable by climate change, the level of exposure has expanded, and so the distant infrastructure now becomes part of the new vulnerable. And the same thing we can think about for infrastructure, we can think about for other groupings. And so our environment, flora and fauna, are among the new emerging or the emerging vulnerable groups, because the changes in temperature are pushing the envelope within which they can survive. And other vulnerable groupings are people like outdoor workers who are facing harsher conditions, or asthma sufferers, or the chronically ill, or the elderly, the young, the physically challenged, and small business owners who are the first people usually to feel the impact when the labor force pulls out because they are sick due to a new emergent disease, not talking chickpea necessarily, or when the labor force is impacted by an extreme. Can you see that climate change is altering the vulnerability that we used to know by altering the levels of exposure? And let me push it one more point, one more step. In the new climate change, it's not only changing the levels of exposure, but it's challenging our capacity to cope. In this case, it's not the intensity of the climate change. It's not that we're getting more severe thing, but it is the recurrent nature of the extreme. So if I put up this table from the Planning Institute of Jamaica, you immediately see what I'm saying. In 2001, we got hit by Michelle, and it was 8.8% of our GDP. And then in 2002, we had flood range, which contributed 0.7% of our GDP. Then Charlie in 4, and if we thought we got our quota for 4, then Ivan came with 8% of our GDP impact. Then Dennis and Emily in 5, Wilma in 5, Dean in 7, Gustav in 8, Nicole in 10, and Hurricane Sandy in 12. Can you see the challenge climate change is putting up to our capacity to cope? It is really not hard to conjecture that the impact of recurring climate extremes in the recent past easily surpasses any of the economic contingencies that would have been put in place to accommodate the normal variations of climate. As our capacity to cope nears exceedance levels, our vulnerability is being transformed. What am I trying to say then? I'm trying to say that the second thing that describes the state of the Caribbean with respect to climate is vulnerability. The first in my reading is sensitivity, the second is vulnerability. And it tells us what the climate is demanding. Because if sensitivity is demand saying, pay attention to climate, then vulnerability is saying, give consideration to climate. When you are planning, at least put climate as a bullet point, even if it's the last bullet point. But vulnerability then becomes variable B in Taylor's equation of state. What then is variable C? Let me give you a third observation. My third observation is that in my contextual reading of the Caribbean's current state, this is what I see. There is clear recognition of need for action, but evidence of action is frustratingly absent. or limited. What then becomes variable C? Variable C is inertia. Let me try to put it together. So, why do I say this at all? A little more science. I promise the last bit of this is the science of what we do at the University of the West Indies in the Climate Studies group. We do the science of modeling. And what is the science of modeling? The science of modeling tells us, well, if we can take storylines about how the climate is going to change as we go to the end of the century, the world is going to change as we go to the end of the century. So we take storylines, the world may become more developed technologically, or the population may increase and then decrease, or we may become more globalized. But we take all of these storylines and we can calculate what the CO2 emissions are going to be related to these storylines. Then it means that on the left, we can come up with different scenarios of emission. So if you look on the left, you can see that one scenario just starts and continues rising to the end of the century. The CO2 never stops increasing. That's the worst case storyline. And then if you look in the middle, on the same panel on the left, you can see one of the lines goes up, but not as high as to the other. And then if you look, same panel on the left, at the bottom line, it goes up to the middle of the century and then comes down. That for us is the best case scenario. Interestingly, of all the scenarios, the CO2 continues increasing to the middle of the century. We never have a scenario of the CO2 going down. Well, if I can take all of those scenarios and I can plug those scenarios into a model, and the model is just a computer-based model where all the physics of the climate is